Hello everybody, I'm Coach Sonny, and I'm going to just really quickly explain how a binary search algorithm works. Basically, it you have a number of elements and then you need to cut it in half and then check both of those halves and then continue into a smaller half and a smaller half and a smaller half until you find the thing you're looking for. Okay? Now in this case, I have down here a row of numbers right here, and they're all sorted, meaning that they go from smallest to greatest number. So it starts at 4, ends at 200, and it's random. There's no pattern that I can think of. I just randomly put numbers in there. And now imagine that I want to put this other number, 103. I want to put it in the right spot. I want to put it where it belongs in this ascending order. Okay. Now, because we are humans and we have eyes, we can simply just by looking at the numbers tell, well, it's gonna go between 99 and 107 because 103 is bigger than 99 but smaller than 107. The problem is that computers don't have eyes like us and they don't read information the same way. So for example, what a computer would do is it would start in the first slot. So it'll ask, is 103 greater than 4? And then the answer is yes, and then we'll go over here. And then ask, is 103 greater than 9? Yes. Greater than 15? Yes. Greater than 16? Yes. 25. And then it'll keep asking until it gets to this number. And then the answer will be no, it's not bigger than 107. So then it'll put it in between these two numbers. And maybe because there's only 60 numbers, it won't take that long. But imagine you have a million numbers or a billion numbers, because that's usually like, the size of files in our computers. Videos and images are like megabytes of size. They're really big. So there has to be a faster method. And there's several different methods, but one of them is using a binary search. And to do that, it'll look at the whole thing and then divide it in half. So for example, we have 60 numbers, so 1, 2, 3, 4, 5, 6, 7, 8. So this would be half point. Now what it does is it'll check this number. Is it bigger than 84? The answer is yes. So then all of this it ignores. It won't check anymore because it knows that it's not going to go in that direction. And then it uses this other thing. And it'll split it in half. So half would be 4 and 4. And then it asks the same question with this last element. It'll ask, is 103 bigger than 135? And then the answer is no. So then it'll ignore this other half. And then it'll check here. And it'll ask, for this guy right here, is 103 bigger than 99? Yes. So then it'll ignore this and then continue to this one. And then cut it in half. And then ask, is 103 bigger than 107? The answer is no. So then it'll put it right here. So 103 would go in this spot that we already knew because we could just see it, right? But that's how binary search works. Simply cut something in half, checks the first part, second part, and then it chooses one, ignores the other, and then the part that you're left with cuts it in half again, so on and so forth. This is also useful for when a computer is like putting something in order. So let's say the next number is, let me get rid of all my scribblings. Let's say it's not 103, but it's 162. Like that. Same process, cut in half. Is it bigger than 84? Yes, so then ignore all these. And then cut in half again. Bigger than 135? Yes. Ignore these. Cut it in half. Bigger than 158? Yes. And then bigger than 167, no. So then it would go right here. So the same process, and then more numbers will be added to the series, and it'll grow and it'll grow. And then this method would make it faster than to check one by one by one. Okay, so make sure you continue with the assignment, and that's all for today. See you later.